Assalamu alaikum. Today's topic is going to be about resolution of vector into its rectangular components. Let us define the rectangular components. The process of splitting a vector into its components is called resolution of a vector. It is the reverse process of addition of vector where we join two vectors by head-to-tail rule. In resolution of a vector, a single vector along with its direction is converted into two components, one horizontal and one vertical. For that purpose, let us consider a force vector F which makes an angle theta with x-axis. In order to find its rectangular components, draw a perpendicular on x-axis and y-axis as shown in figure. So let us consider a y-axis which is vertical, an x-axis which is horizontal, and this is the force represented by a purple line and an arrow which is representing a force F. Now we are basically splitting it into two components, one vertical which is represented by Fy and one horizontal which is represented by Fx. But we have to explain this whole process in terms of segments. And this is the angle of that vector which is represented by theta. So we name all of these points. Let's call the point of origin called O. Let's call this point P, and let's call this point A. OB and AB are called rectangular components. That means the horizontal part is OP and AB is the vertical part of a given vector F because they are right angle with each other. That means they are making a 90-degree angle with each other. Since OB is along x-axis, therefore it can be labeled as Fx. OB is along the x-axis, that is why we are calling it Fx. And AB is acting along y-axis, therefore it can be labeled as Fy. And AB, which is a segment over here, can also be called Fy. In order to verify how or why they are called rectangular components of F, we can add them according to head-to-tail rule. The resultant F can be achieved as shown in figure. That means, as you can see, head-to-tail rule, one vector ends, the other vector starts, and the resultant vector will be a combination of the two vectors, and which is basically showing the combined effect of vector Fy and Fx. In order to find the magnitude of Fx and Fy, consider a triangle OAB, OA and B. This is the triangle which we are talking about, which is right angle triangle as we know. It is right angle triangle because one of its angle is 90-degree, which is angle OBA. Now we have a figure, we have force F. Now we are basically want to find out the components of the vector, magnitude and their direction as well. In order to find the magnitude of Fx and Fy, consider a triangle OAB, just like I showed you before, which is a right angle triangle as you know. For the horizontal part, we consider a function of mathematics called cos. Cos theta is equal to base over hypotenuse. Over here the base is Fx and the hypotenuse part was Fy. So rearranging them, we get Fx is equal to F cos theta. That means this line Fx will be now called F cos theta because of this vector F, and theta is the angle of this vector which is represented by purple arrow with the horizontal part. Let us call this equation number 1. Similarly, for the vertical part which was over here, we take sine, and sine means perpendicular over hypotenuse, where perpendicular part was Fy and hypotenuse was F. So we rearrange it, we get Fy is equal to F sine theta. That means this part can be represented as Fy is equal to F sine theta. We call it equation number 2. From equation 1 and equation 2, we have the magnitude of Fx and Fy, and it can be calculated. These, after knowing the force or the vector of force and the angle, we can find the horizontal component as well as vertical component. In equation 1 and 2, angle theta, which makes F with the positive x direction in anti-clockwise sense, that means we can find out the direction of these two components now. The method to find the resultant of the rectangular components of the vector. Now, how we can find the rectangular components of the vector? If fx and fy are given, then their resultant simply by adding according to head-to-tail rule, which is not according to the scale, because scale diagram is not required in this case because we are doing it mathematically. So head-to-tail rule is being applied over here. So where one vector ends, the other vector starts from there, and the last vector, the resultant vector, will show after joining the head of the last vector with the tail of the first vector. A right angle triangle form as shown in figure. To find the magnitude of the resultant f, apply Pythagoras. What is Pythagoras theorem? Pythagoras theorem said that hypotenuse square is equal to base square plus perpendicular square. This line is representing the hypotenuse, this is the perpendicular which is of red, and the blue line which is the base. Putting in the values, we get f square, which was the force which we want to find out, is equal to fx, which we already found out over here, fx, plus fy, which is the vertical force. It can also be written as f is equal to under root fx square plus fy square. Now we are calling it equation 3. This is representing the magnitude of this force. The resultant force F is being found out by magnitude of these two components, the horizontal as well as vertical. Now to find the direction, we have to find the direction. For that we need theta. For that we use a function of mathematics again, that is tan, which represents perpendicular over base. The perpendicular is Fy, the vertical part, and the base is Fx, the horizontal part. Now the theta can be easily found out by theta is equal to tan inverse, taking the tan to the other side, it will be tan inverse Fy over Fx. Now in this way we can find out any direction of any vector which is placed inside our coplanar rectangular components. We are calling it equation 4. So equation 3 is for the magnitude and equation 4 is for the direction of the vector f. Equation 3 and equation 4 can be used to find magnitude and direction of the resultant in three-dimensional case. Now, if these were only two-dimensional, x-axis and y-axis, what if there were three axes? Z-axis was also involved. For that purpose, we have a formula f is equal to under root fx square plus fy square plus fz square. So student, what we have learned today about the resolution of vector, the breaking up of vector into its component is known as resolution of vector. Thank you so much. Inshallah, we'll meet again.